Okay, so hello again. We're going to continue with our videos in mathematics in the modern world. And here I'm going to cite one example of the Pascal's triangle in action in the binomial expansion. So remember that I have promised you one video that will show you one particular example wherein there's no x and y. Rather, the x and y is in terms of another term, of different terms other than x and y. And we're going to apply it. We have 2a minus 3, and notice we have a subtraction rather than our usual addition, all raised to 4. So let's take a look at this example. So first up, we have 4 as our degree. So we're going to take a look at the Pascal's triangle in the fourth row. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And the fourth row is 1, 4, 6, 4, 1. And this is what we need to expand this binomial. So how do we do this? We put first the coefficients. So we have 1, 4, 6, 4, and 1. And as usual, we're going to make this as our x, this is our y, and then we're going to start with our x all raised to 4, and then our y all raised to 0, and then we're going to increase the y and then decrease the x. So in this manner, we have 2a. This will be all raised to 4, and our 3 or negative 3, we're going to take that as negative 3, okay? Raised to 0. Plus, we have 2a raised to 3 times negative 3 raised to positive 1, plus we have 2a raised to 2 or squared, and then we have negative 3 squared as well, plus we have 2a raised to 1, negative 3 raised to 3, plus we have 2a raised to 0 times negative 3 raised to 4. So let's take a look at this and then let's expound this. So this will become 1 times 2a raised to 4, 2 raised to 4 is 16, a raised to 4. That's going to be times 1 because this negative 3 raised to 0 is going to become 1. Plus, we have 4. 2a raised to 3, or cubed, is going to give us 8a cubed times negative 3. Plus, we have here 6 times 4a squared. That's 2a quantity squared. 4a squared times positive 9, since negative 9 squared is going to become, or rather, negative 3 squared is going to become positive 9, plus 4 times 2a times negative 27. So the 3 cubed is 27, so that's a negative 3. That's going to be negative 27, plus 1 times 1. This will become 1, right? So this will become 1, as well as this will become 1. So we have here 3 raised to 4. That's going to give us 81. 3 raised to 4. Going to give us 81. Yeah. So that's raised to an even number. So that's going to become positive 81. So let's fix this. On the first term, what we have is that's times 1 times 1. So we have 16 a raised to 4. This becomes negative since we have a negative sign here. So we have 4 times 8 times negative 3. So that's gonna give us negative 96 a cubed, plus we have 6 times 4 times 9. That's gonna give us 216 a squared, plus we have negative 27 times 2 times 4. That's negative 27 times 8. That's going to give us negative 216. So instead of plus, this becomes negative 216a, and we have plus 81. And this is going to be our answer for this binomial expansion of 2a minus 3 raised to 4. So some important notes to take note here, or key points to take note here, is that if ever we have a negative sign as the operation between these binomials, the flow of the final answer would be plus, positive, negative, plus, positive, negative, positive, and negative, positive, and so on. So meaning it's an alternate plus minus signs, positive and negative signs, so that you'll be guided. So um, that's one tip that I can give. All the others are actually, you just need to not get lost along the process. You just need to be careful with all the steps that you're taking, or else you'll get a pretty nasty result. Okay, so 6. Let's try to double check our answers here. Actually, they're all okay if you want to double check. So that's it for this video. At least I have given you one example of the Pascal's triangle in action in the binomial expansion. So thank you very much for watching.